Hi everyone. Today we're going to be kind of solidifying what we talked about in the second exponent rules investigation. And so we're going to come up with rules and we're going to be calling this the power rule. So we're going to go through a couple examples here, kind of revisit what was the pattern that we found, and then come up with some specific rules. So the idea for today is when we're taking a power, like this 3x to the fourth is our power, and we're raising that to another exponent. So that's the situation we're looking at today, when we're taking a power and raising it to another exponent. So our goal here is to simplify this. So when I'm simplifying, it means I want all of my parentheses gone, and I just want to write it as a single power. So if I have 3x to the fourth to the third power, it means I'm going to take my power, 3x to the fourth, and multiply it by itself 3 times. So if I'm going to expand this, I have 3x to the fourth times 3x to the fourth times 3x to the fourth. Now if you prefer parentheses, that's fine. We can write it either way. But we're going to have 3x to the fourth times itself 3 times. Now we could take this out and expand it even further. So for this factor, I could write 3x to the fourth as 3 times x times x times x times x. I'm going to do the same thing here. So I have another times 3 times x times x times x times x. And then I've got one more factor here. So now I've fully expanded this, and now I want to simplify. So the first thing I notice is I can take all of these numbers that I have here, and I can multiply those together. So 3 times 3 is 9, times 3 is going to give us a 27. And then I can look and find all of my x's. So I've got 4 x's plus 4 more is going to give me 8 x's. Plus 4 more x's gives me 12 x's, so I have x to the 12th. So what I know is this 3x to the fourth to the third power, that's going to simplify to 27x to the 12th. So now what we want to do is look for patterns. And probably what's going to jump out at you quickest is that this 12, we can get that by doing 3 times 4. So by multiplying those exponents together. We're going to use the same idea with this 3 because we know if there's no exponent present, that exponent is just a 1. So if we do 3 times 1, that's going to give us 3. 1 times 3 is to the third power. X is going to stay, and then I have 4 times 3 is to the 12th power. Now, we can use our calculator to do 3 to the third. It's just 3 times 3 times 3, which is what we had here. And that's going to simplify to 27x to the 12th power. So when we have a power raised to another exponent, really what we're going to be doing here, you can think of it kind of like when we did the distributive property. We're going to distribute that exponent to each exponent inside the parentheses. And when we do that, we're multiplying those exponents together. So for a pattern here, we're going to say when a power is being raised to another exponent, we multiply the exponents. And so I'm going to put kind of as a reminder here, the idea is that we're kind of distributing that exponent that's outside the parentheses to each exponent inside. And just like before, when we distribute, we multiply. So for our rule, it's going to look like this. If I have x to the m power, and I'm raising that to the n, we know our base is going to stay the same. So that base that was x stays x. And then we're going to multiply those exponents. So the m and the n get multiplied, and the new exponent becomes m times n. So let's look at a different example. It gets a little more complex, but it's going to use the same basic rule. So I'm going to move over here. So now we have 4x squared over y to the fifth. I've got a quotient, and we're raising that to another power. So the idea here is we're going to, again, just look at this by expanding it. So if I have this whole expression, and I'm raising it to the third, that means I'm going to write this, what's in the box, 3 times. So I have 4x squared over y to the fifth times 4x squared over y to the fifth times 4x squared over y to the fifth. And so now again, we can take each factor and expand it further. So for my first one here, I've got 4 times x over y times itself 5 times. If I take my second factor, I'm going to do the same thing. And for number 3 here. All right, so now if we're going to simplify this, we can take our 4 times our 4 times our 4. It's going to give me 4 times 4 is 16 times 4 is 64. That's going to stay up top. If I look at all of my x's, I've got 2 x's plus 2 more is 4 plus 2 more is 6. So I have x to the 6th power. And then on bottom I have 5 plus 5 more is 10, plus 5 more is 15y, so I have y to the 15th power. So if we kind of go back like we did last time and think about that idea of distributing, I can see I'm going to have the exponent on the 4 is a 1, so 3 times 1 is 3, so I'm going to have 4 to the third. There's no variable there. Now, x has an exponent of 2, so 3 times 2 is going to give me x to the 6th power. And you can see on the bottom now, I also have to take that 3 and multiply it by the 5, so I get y to the 15th power. And if I were to simplify this in my calculator, 4 to the third, I do get 64x to the 6th over y to the 15th power. So as far as our pattern, we're going to have the same pattern. The only thing we need to remember now is down in the denominator where I have this power, I need to multiply those exponents in the denominator as well. So if we want a more general rule that includes this case, we're going to look at something like x to the m over y to the z, so some other power. If I raise that to the nth power, we're going to distribute, so I'll have x to the m times n over, I'm going to distribute here as well, and I have y to the z times n. And that would be our rule. All right, so we're going to go through some problems now, so you can see some examples before you start the practice. All right, so we're going to simplify each of these using the rules, but then we're going to kind of check them by writing out the long way by using our expansion. So we said our rule is that we're going to multiply. I have a power raised to a power, so we're going to multiply the exponents. Now again, the key here is this 3 has an exponent of 1. So when I multiply, I'm going to get 3 to the 6th power. Here my base of x has an exponent of 5, so 6 times 5 is going to give me 30, so I have x to the 30th. Now we're going to use our calculators. If you type in 3 to the 6th power, I believe that should give us 729. We'll just use our calculators for that, times x to the 30th power. Now again, we can check this by writing it out the long way. Our power was 3x to the fifth, and we know we have that 6 times. So we're going to have 3x to the fifth, 2, 3, 4, let's see, 1, 2, 3, 4, 5, and 6. So we would start by multiplying all our constants. So 3 times 3 times 3 times 3 times 3 times 3 is going to give us 729. Now, here's where we can kind of be smart and use rules we've already learned. I could, for each of these, write x out 5 times. But we said if we were multiplying two powers with the same base, we would just add up all of the exponents. So I can use that rule from day one. If I have x to the fifth times x to the fifth, right, I have that 6 times. I know I'm going to keep my base of x the same, but I'm just going to add all these up. So 5, 10, 15, 20, 25, 30 is going to give me my exponent. So whether you use the long way or using the rules, you'll get to the same answer. Obviously, rules are just going to be a little more efficient in getting you to that final answer. Okay, let's look at number 2. Again, we have the same rule. We're thinking of distributing that exponent. So the exponent on 2 is a 1. So I have 4 times 1 is 4. So I have 2 to the 4th power. Here I have x to the 5th raised to the 4th power. So 5 times 4 is going to give me x to the 20th power. Now I have to remember on the bottom I also have to multiply these two exponents. This exponent needs to get distributed everywhere inside those parentheses. So 7 times 4 is going to give me y to the 28th power. So now the only thing to do is simplify. I know 2 to the 4th, you can use your calculator. If you have questions about how to put these exponents in, please make sure you ask. 2 to the 4th is 16 times x to the 20th over y to the 28th. And we're going to stop here. Remember, we can't use that subtraction rule because our bases here are not the same. So those are going to stay separate. All right, we'll do this last one using the long way, and then for the rest we'll just use the rules. So this tells me I have my expression here, my power here, 2x to the 5th over y to the 7th. I have that 4 times. So I have 2x to the 5th over y to the 7th. Now, when we're multiplying by fractions, remember we always just multiply all the numerators, the things that are on the top. Those are going to stay in the top. So I have 2 times 2 times 2 times 2. It's going to give me 16. Now, I have x to the 5th here. Since these are all a base of x, my base is going to stay the same. And since I'm multiplying those, I'm going to add the exponent. So 5, 10, 15, 20. On the bottom, I can also just multiply right across the bottom. Again, I'm multiplying powers. Their base is all y, so that's going to stay y. And I'm going to add the exponents. So 7, 14, 21, and 28. So I can just check that I use the rules appropriately. All right, now the last two, we'll just do these using the rules. So again, I'm using my power to a power, so I'm going to multiply those exponents. So I have 4, the exponent is 1. So 1 times 3 is 3. For x, my exponent is 7. 7 times 3 gives me 21 over x to the 5 times 3 is 15. So if I evaluate this power here, I get 64 times x to the 21 all over x to the 15. All right, and last but not least is kind of an example more, looks like what we started with. Again, the idea is just to distribute that exponent. Here I have to distribute it 3 times. I need to make sure I multiply by all of the other exponents on the inside. So I have a base of 4, 1 times 3 is 3. For my next power, my base is x, and 6 times 3 gives me an exponent of 18. And lastly, for y, I have 5 times 3 is 15. All right, so that's our third rule that we have so far. And for the rest of class, you'll be doing practice with this new rule. All right, good luck. Thanks.